I'm here replacing Roy Bateman, who is a honest-to-God specialist in biological control agents. I had about 7 years' experience before I returned to the ag chem industry. But one of the reasons I'm here is that Roy and I, along with a guy called Roger Downer, wrote a book chapter about the theoretical underpinnings of biological control agents and pesticide application, how they're sprayed and what really happens. It's not light reading, it is really quite theoretical, and it underpins most of what I'm going to talk about. If you want a copy, let Roma know, but as I said, it's heavy going. I'm going to talk through some of the basics, biopesticide application and formulation. Then in this bit, the biopesticides as particles, that's what's I really want to get into. And where is the biopesticide going? And where is it in the spray cloud, which is also a rather interesting subject if you haven't thought of it before. And then some conclusions. Good starting point is this book. It's Pesticide Application Methods by Graham Matthews. It's been around about 30 years. It's in its 4th edition. If you're interested in spray application in any form whatsoever, you'll have either an excellent starting point or really up-to-date research is found in that book. You can't really do any better. You may also notice that Roy Bateman's in this as well. I mean, Roy Bateman really knows his stuff. So, some preliminary thoughts. All of you have basically got 2 sorts of capital in your systems. The financial, I mean, that's just basically what is used in the production process, equipment, labor, all those sorts of things. But there's also this thing called intellectual capital, and that's how to best use your pest control methods. Now, my company and others produce chemical control methods that are immensely robust. There are great margins of safety in the use of these products. Most people know that and can reduce the rates. We know this happens. They've got label recommendations which are quite wide. You can apply them, say, in broadacre agriculture, a range of speeds with different sorts of nozzles at different application volumes, and they work. And we will stand behind those label recommendations. They are very, very robust. Biological control methods are not. They're much more fragile systems. They're a much smaller window of change you can apply to them, and need a lot more thought. And the moment, as Dick was talking about, the moment you step into integration of chemical and biological methods, you need even more thought. This is not low tech, okay? This is a thinking man's operation. That basically is my message for the entire talk. You must think about this. There is not a tick box approach to this. It needs thought. So, for example, assuming that what works for chemical applications is going to work for biologicals, that really has to be reassessed. So if you're playing with different surfactants, I mean, there's a classic. Most arable crop farmers like adding things to spray tanks to try and make them work better. And almost all agrochemicals are fairly resistant to that sort of playing around, and maybe you do get an improvement and maybe you don't. You try that with a biological and basically you're on your own, because a lot of biologicals do not like surfactants. So you have to be much, much more careful about how you play around with these things. Biocontrol is basically about effective inundative control. I mean, we're coming back to this. Several speakers have already mentioned this already. These things are not systemic. You have to use the application system to get the biological control agent to where you want it to operate. And here's a really good case from Roy's work using Metarhizium acridium in its original form against the desert locust. You have to get it to the locust. The locust doesn't come to it. You have to, now this is where formulations get really important because it's a fungus and it doesn't like drying environments like the Sahara where it's actually used. And the formulation means, first of all, you get this maintenance of viability on the shelf so it survives, but also maintenance of viability when it's actually used in the field. And that's important. So formulations are a key component of biological control agents. This would not work without the formulation component. And lastly, there's the appropriate application. Well, in this case, the appropriate application is trying to get lots of very small droplets out over a very wide area over all these locusts that might be over hundreds of square kilometers, quite literally. And they use things like this. I mean, maybe some of you have seen these things, probably not in this country, but that's an exhaust sprayer with probably some sort of rotary cage at the top by the look of it, maybe not. But that's how you do it. That's the appropriate application system. As I said, and it's been said before, very few biopesticides are systemic. Application becomes much more important. And this is where a lot of the unforgiving nature of biopesticide application comes from. So, Improved delivery systems. Well, if you've got an underperforming biological control agent, then messing around with the formulation and the application system probably won't rescue it. So as a starting point, the companies that produce these things, they have to have have to have a reliable biological control agent that's delivering a reasonable level of, I dare use the word, control. But the reverse is absolutely true, that if you do not pay attention to the application system in particular, as well as the formulation, although that's basically beyond your control, you can reduce substantially the efficacy of your biological control agent. Application becomes very important. So there are some basic rules, and this applies across the entirety of spraying, whether you're spraying thousands of hectares of cereals or you're spraying a small plot of herbs for some particular market. Tank agitation is important. You've got to keep these things up. Formulations won't help a great deal in this because it's not the sort of formulation exercise that works with biologicals. Good emulsions, good EWs, good ODs, these all stay up in spray tanks. They're designed to. But tank agitation is really quite important for biologicals. Nozzle choice and calibration, well, we'll come back to nozzle choice in a while. But calibration, I mean, not just changing nozzles every few years, but calibrate them. When you calibrate your system, you'll know what it's delivering in terms of liters per hectare, and it will also tell you whether you're getting any of this. Now, we're 20 years on from when people used brass nozzles and they used to wear out every season. I mean, similarly, stainless steel nozzles. Now we've got these brilliant plastic nozzles, and if you've got a very corrosive system, you can use ceramics. But they do wear with time, and there's nothing you can do about that, and calibration picks this up. Nozzle wear will mean that you're over-applying, and that's a mistake. This has been addressed, spray line cleaning, because obviously if you've got a fungicide left over in your spray tank, you're going to try and spray a biofungicide like Ampelomyces quisqualis, you'll probably kill it. But there's the other thing, the other root of problems with spray line cleaning is that some of these botanical oils are great spray tank cleaners. And if you've got residues in that spray tank cleaner, they'll strip them out and you'll have phyto problems, maybe, who knows. So that's actually quite an important point. The last one's very minor, in a sense, is spray drift. As a rule with biological control agents, you don't have issues with spray drift. But spray drift is one of those visible things, so if you're spraying outside, and the general public see you spraying and spray drift is very visible, they don't know that what you're spraying is perfectly safe for the environment, and you may get yourself a headache that way. So that's worth bearing in mind, not so much for efficacy reasons, but certainly for public relations. So, biopesticides, they're all particles, and they range from the immensely small granulosis viruses like this, which are down at the point where you can't see them even with a really top-end light microscope. You need an electron microscope to see these things. Bacteria, this is Bt. There's the crystal in there that does all the damage to the lepidopterans. That's about 2 microns by 1. Here you've got Metarrhizium anisopoli. I mean, that's 13.6 microns. So you can see these things are substantially bigger than bacteria. And here you have these elephants of entomopathogenic nematodes, and they're enormous. They range from 300 to 800 microns. And the bigger ones you can see with the naked eye if you get close. A big range of particles and sizes, but they are all individual particles. Not soluble, nothing like that. They're particles. So, going back to what to do. You can't control the formulation, okay? That's up to the companies that supply the products to you. And as you get more and more products available in the market, you'll get changes in the way people formulate things, and it's up to you to find out which companies are providing you with the better formulations for delivery. That's basically that is beyond your control, except in terms of choice. But what you can do is control how the biopesticide is actually applied. Now, that application system is generally what is available in the market. So going to Central African Republic and telling them that they have to spray a locust control agent with a 36-meter boom at 300 liters per hectare is just madness. Similarly, going to growers in the UK and telling them that they have to hand spray with spinning discs, cereal crops, is equally madness. But there is a middle ground, okay? And that middle ground has got some room for maneuver in terms of things like spray volumes and the choice of nozzle. Formulations, well, they ought to be compatible with your existing equipment. But again, you have to be careful with that and look at what's on the label. And more information will get onto labels, and more advice will come onto the labels as this market for biopesticides matures into something approaching that we've got with agrochemicals. But again, we're back to this issue that you should not assume that what you've got for your existing application equipment is automatically appropriate for what you're going to do with a biopesticide. What you use to spray an insecticide to control insects may not be at all appropriate for what you might use to apply a biopesticide to control exactly the same pest. This needs thought. We're back to my central message. You need to think. Okay? Now, you can step outside the usual application systems. You use your brains, you think about it, but you must be very careful. Okay? Why is the label written the way it is? Someone didn't just put it there for fun. Someone wrote it down for a good reason. So if it says a drench application, and you would decide that, well, actually, no, I'm not set up for a drench application. I'll go with the 200 liters, 400 liters per hectare that I've got set up at the moment. Well, that's probably not a good idea. Okay? Think it through. But let's say it's an entomopathic genetic nematode and you want to use less water. You may go for very large droplet nozzles and still go with relatively low volumes and get them down into the soil through the canopy. It needs some thought, that's all. So, where do the particles go? This gets a bit theoretical, but I'll go through it step by step, so I hope you can follow what I'm getting at. Concentration of particles in the suspension is the number of, say, conidia you've got in a liter. Okay? And these actually are quite big numbers. We'll come back to that in a minute. Then you've got the droplet size spectrum, which ranges from extremely small droplets around about, say, 10 microns, up to really, really big droplets. Now, in broadacre agriculture, you're not like to see anything above 700 microns, but with the systems I hear about being used in horticulture and ornamentals, you're up to things the size of raindrops, and quite big raindrops at that. We'll come back to that in a minute. And then we're down to things of the size of particles. First of all, will they even fit into the droplets you're generating? And for things like viruses and microbial particles like fungal spores, I mean, how many will fit into the drops? And this becomes important. Drop size spectra is relatively easy to find out. Not your problem. It's measured by people with lasers, and we can figure out all this information. That's not difficult. Where the biopesticides are, in terms of their sizes and so on, there's a very, very large range. As I said, okay, here's the viruses, tiny. Can't see that with a microscope. And there are 1 times 10 to the 12, which is a trillion particles per hectare are applied, and they're applied in sort of moderate volumes to ultra-low volume application rates. Come down to the entomopathogenic nematodes. These are enormous by contrast, 1,000-fold larger at least. There's only about 1 billion, maybe 10 billion used per hectare, and hence because of their mode of action, you're often using a drench or high volume to get them into the place. And then you've got everything in between. These, by contrast, are absolutely enormous at one end of the spectrum. Here you've got something really tiny, a low rate per hectare, a very high rate per hectare, a high application volume, and then for things like Bacillus thuringiensis and so on, low volume, and for microinsecticides, even ultra-low volume applications. There's a whole range of things to be done here depending on what you're actually trying to apply. This is the droplet spectra, ultra-low volume and hydraulic, okay? Hydraulic nozzles, we're all familiar with flat fans. That droplet spectrum ranges from about 20 microns up to about 1,200, depending on the pressures you're using. Hollow cones have a slightly narrower spectrum, okay, not much, and your spinning discs have a really much narrower spectrum in terms of the drop sizes. Here's the point I'm getting across here. 1 picoliter is way down here, about 12.5 microns. 1 nanoliter is at about 100 microns, or a microliter is about 1,200 microns. If you read the book chapter, which I don't recommend, you'll come to this is all explained there, okay? And what we're looking at here is the probable loading of a particle in a droplet. How many particles go in that drop? And this is 5 times 10 to the 9 particles per liter, so in terms of, say, 200 or 300 liter per hectare application, we're talking about something like a microinsecticide, okay? Or Amplomyces quisqualis, one of those sort of products. Anything under about 100 microns has got about a 50% chance of containing a single particle of a bioinsecticide. anything at about 10 microns has probably got about a 1 in 100 or less chance of containing a particle. So there's not much going on down here. You're delivering droplets with nothing in them from that point on. Up here, there's lots of particles in your drops, okay? 150 microns, often, we'll come to the numbers in a minute. But there's a problem with anything bigger than 150 microns. It tends to bounce off leaves. So you may have got a droplet there with lots of your biopesticide in it, hits a leaf, bounces off, a bit like a bullet. Now, in a fairly dense canopy, that's not too worrying because it bounces off, shatters, and maybe distributes into the rest of the canopy and is caught because all of its kinetic energy is gone. But if the canopy isn't so dense, or it's a very large droplet, it hits, bounces, and goes straight to the soil. And that's just wasted. Completely wasted. And because of this volume ratio to size, there's an awful lot of waste going on up here. What you're wasting down here in terms of droplets, you know, that maybe drift away or don't impact properly, is trivial compared to the waste you're seeing up here. To put this into some sort of scale for you, I mean, I've been working with this on most of my working life, so I have a feel for this. But this is actually, it's difficult to get this conceptually. There's your 12.4 micron droplet, picoliter. There's 224, a nanoliter. These are good. They impact on leaf surfaces. This is a 1 microliter droplet, 1,240 microns, a very small raindrop. That is no way going to impact on a leaf surface and stay there. It will just bounce, shatter, smash, roll off. It just, to get some sort of scale, if you won the pools and you won a couple of million pounds, sorry, you can tell where I live, a couple million pounds, that's what you get. If you're Bill Gates, that's what you own. And if you're the United Kingdom, that's the national debt. So the range here is enormous, okay? And it's difficult to get inside one's head exactly what's going on in here. That maybe contains nothing when you're delivering biopesticides. This has got quite a good dose in it for many of them, and this has got, well, vastly more than you really need. And you can see this. Here's our 3 droplets. So viruses, that little tiny droplet there, because you're putting so many out here, say 2 trillion viral particles per hectare, there's probably 4 viral particles in there. Is that enough to kill an insect? I don't know. If you go to the other end of the spectrum, those enormous great entomopathogenic nematodes, which may be anything from 300 to 800 microns long, well, you're not going to get one in there, are you? I mean, actually, you'd only get 3 into that. So your delivery systems are now wildly different. So what are you trying to do? With mycoinsecticides, 124 micron droplets has got about 30 spores in it, or 30 particles. And this is the sort of thinking that goes on and underpins how you should apply things. The point being, though, that these really big droplets, they're not going to impact. They're just going to bounce off. Total waste. So if you're applying droplets here, let's say these bacterial fungicides, and that's a good dose to get in there with a 125 micron droplet, and you go and start applying them like that, there's 1,000-fold more active ingredient in that drop than that drop, and it's probably wasted. Application is really important here. So, where are you going to put it? We've already heard some people talking about using high-volume applications to get droplets underneath leaves. There are various ways of getting droplets underneath leaves, and that's probably one of the most wasteful ways of doing it because you're using you're using the spray as a means of delivering, right, and moving the leaves around in order to get droplets to impact underneath. There are better ways, need some equipment, but things like drop leg booms, which spray up, or you can use the same technology that's used in arable crops for vegetable growing, where you use band sprayers, which spray sideways. There are all sorts of different ways of getting at the target. In this case, it's the whitefly, it's underneath, and you can see what's going on. It doesn't have to be knapsack sprayers. You can tow these on booms or move them through glass houses on booms. It can all be done. And there's quite a lot of research being done on this. I hear about it every couple of years at the Spray Application Conference that's held in the UK every year. Lastly, and this is one of Roy Bateman's pet hates, are we trying to apply 21st century control agents using application methods that have changed little since the 19th century? And that applies as much to what I mainly work now with, which is agrochemicals, as it does to biochemicals. These days, get an agricultural chemical to market, you're spending between 80 and 150 million euros. Okay? Biologicals are much, much cheaper to develop and register. And yet we're still using something that Archimedes would have understood if you had explained it to him. It's really quite strange. However, something that is used in the protected and edible crops business is these things, which are variable cone nozzles. And these allow you to change the droplet spectra by twisting the thing at the end, and you either get a long spray so you can reach out over a good distance, or a fine spray in close. Okay? They come all over the place, and one of these, I can't remember which one it is, I think it's that one, is applied on most Chinese knapsack sprayers. And one of these, according to Roy, is one of the most common nozzles on the planet. And they're adjustable. What that means is that when it comes down to calibrating your nozzles, it's impossible. I mean, this is a calibration curve. I won't explain it, but the conclusion you can come to from these different lines here is that calibration is impossible, and this is in a laboratory with pressure gauges and lots of pumps and people with lab coats and stuff running around. But I mean, if you cannot calibrate your sprayer to get a reasonable application system, how do you expect your biopesticide to deal with an application system which you can't control? So these are called Reaper sprayers. I mean, this has been an education for me this trip. I haven't heard that one before. But they're effectively lance sprayers run at fairly high pressures with adjustable ends. You've no idea what you're doing with your application now. It's not calibrated. You have no idea. So on that note, a quick summary. The efficacy of microbial products depends on the nature and activity of the control agent. You have to bear that in mind. And its delivery mechanism. Formulation, largely beyond your control. Application, perfectly within your control. The importance of quality formulations is slowly coming through into the biopesticide industry, and particularly as companies like Bayer, CropScience, Syngenta, and BASF get really involved in this, formulation is going to be one of the key things that drive their products. Okay? So you should be seeing better and better formulations from everybody with luck. Application equipment, nozzle orientation, the atomization, these are all practical constraints that you can think through and work on and improve. And perhaps you will see more recommendations on labels. And then starting to think in terms of biopesticides as particles. They're not as robust as ag chem products for sure. Think of them in those terms and you have a much better idea of how to apply the things. All the above requires thought. There's no two ways about this. This is a thinking man's game, thinking woman's game, thinking person's game, whatever, but you have to think, okay? This is not low tech. All the equipment needs to be well maintained and cleaned and calibrated. That's really important. These are the basics. You've got to get the basics right. And then you have to avoid losses due to runoff by over-applying in terms of liters per hectare, thousands of liters per hectare watching it run off. That's just waste going down into the soil. And also, higher volume applications need thought. Once you step above 400 or 800 liters per hectare, start thinking, right, do I really need to do this? Let's think this one through. And lastly, you can use large droplet application system. There's plenty of nozzles out there that deliver large droplets, and they have all sorts of advantages and some disadvantages. But again, you need to think about this as you do it. On that note, I'll stop because I think I've run out of time.